Okay, in this video I'm going to talk about how to write your answer when we have a series solution of a differential equation around an ordinary point. So x equals 0 is an ordinary point. In the previous video we were able to find two different indicial roots, or roots of the indicial equation, meaning two different values of r. Each value of r gives us a relationship between the constants. So we're going to deal with them separately and plug them into this equation. And notice the equation will have Cn, so we'll have to use all the constants. It also has an r in it, so we're going to have to use this r value. Okay, so let's start with the one on the left. So our y, just like when I'm doing ordinary differential equations, I'm actually going to write it out as c0 x to the 0 plus r plus c1 x to the 1 plus r plus c2 x to the 2 plus r, and so on. Although in this case, the left-hand situation, r is equal to 0, so really this is just x to 0, x to the 1, x to the 2. So let's see. I'm going to plug in my r value, c0 x to the 0 plus c1 x to the 1 plus c2 x squared plus dot dot dot. Okay, easy enough. And then we know our c1 and our c2 and so on are these numbers, so let's write them down. Y is equal to c0. I'm not going to write x to 0, that's 1, plus c1, which is c0 over 1 times 1, x to the first, plus c2, which is c0 over 2 times 1 times 4 times 1, x squared. And then I'll write down the next one since we have the next constant. This is c3, so it would be c0 over 3 times 2 times 1, 7 times 4 times 1, x cubed, and then plus dot dot dot. All of these have a c0 in common, and so we could write this as c0 times 1 plus x over 1 plus x squared over 8 plus x cubed over, man, I didn't plan ahead. What is this going to be? We got an 8 times 3 is 24 times 7. Quick, what's 24 times 7? It's 168. I certainly didn't have to pause the video to figure that out. Okay, so we can write our answer this way. And really, we have a constant times the solution, and so this thing in brackets I could think about as being my y1, because we're expecting our answer to be like a c1 y1 plus c2 y2. So all of this is just a solution based on the left-hand side, the r equals 0 case. And I don't know if I'm going to fit it in here, so let's slide the paper up a little bit and then do our second case down below. So our second case, r is equal to 2/3, so rewriting our equation, we're going to have c0 x to the 0 plus 2/3 plus c1 x to the 1 plus 2/3 plus c2 x to the 2 plus 2/3 plus c3 x to the 3 plus 2/3. And I'm going to simplify that a little bit. c0 x to the 2/3 plus c1 x to the 5/3 plus c2 x to the, 8/3 plus c3 x to the 11/3 plus dot dot dot. Okay, and then we have a relationship among the constants, so let's write those out. So our y in this case is going to be c0 x to the 2/3 plus c1, which is c0 over 5 times 1, x to the 5/3, plus c2, which is c0 over 8/521, x to the 8/3, plus c3, which is c0 11 times 8 times 5, 3 times 2 times 1, x to the 11/3. And again, we have a c0 in common. We can factor c0 out, and we can write this as c0 times x to the 2/3 plus x to the 5/3 over 5 plus x to the 8/3 over 80 plus x to the 11/3 over, quick pause again, 11 times 8 times 5 times 3 times 2 times 1 is 2,640. Okay, and so this is our y2. And so if we wanted to write out our whole answer would be y is equal to c1y1 plus c2y2, where y1 and y2 are given above. I am going to point out there's lots of ways that we can write this. We could have left it as 2 times 1 times 4 times 1. We could have combined it into an 8. This guy down here, we could have left the x to the 2/3 factored out. That would have been fine. I decided to distribute in just to show you what it would look like. You can also leave the x to 2/3 factored out front. Either way is fine. So there's lots and lots of ways to write your answer. Again, on a series solution problem, I'm mainly going to be asking you what are the first so many non-zero terms. So typically it'll be the first 3 or 4 non-zero terms. So if I asked you find the first 3 non-zero terms, well, there's the first 1, 2, 3 non-zero terms for y1. 1, 2, 3, those are the first 3 non-zero terms for y2. And then it's not as important that I have a formula for the denominator in terms of factorials or something like that. Okay, so this is my final answer, is y is equal to c1y1 plus c2y2, where y1 and y2 are given above.